Welcome to mathematics. This is our same Mangeya, the maths eagle. Right. So this part is on conditional probability, advanced level mathematics. Then after watching this video, please subscribe, like and share this nice powerful video. Same Mangeya signing in. Let's get started. Right, basic explanations based on conditional probability. Right, conditional probability is we have two events. We're being asked to find the probability of an event given that another event is already occurred. Probability of event A, if you can have events A and B here, we're being to find the probability of A, for example, given that. Use slash. Slash means given that. So probability of event A given that event B is already occurred, then is equals to, then breaking it up down, you say probability of A times, or let me use intersection first, probability of A intersection B over probability of B. So that's how you work out conditional probability. Probability that the child is aged 12 given that she's a girl, right? So it means we are given girls, and from the girls we want to find the probability that the child is 12 years old. That's conditional probability. Then we have conditional probability based on independent events. Independent events, these are events whose occurrence does not affect one another. These are called independent events, right? So probability of A given B based on independent events is equals to probability of A intersection B over probability of B. But since this event does not affect each other, which means you can break down the intersection, it will be probability of A, remember, times probability of B over probability of B. If we can cancel out here, probability of B and B, it will be equals to probability of A. So probability of A given B is equals to probability of A given that the two events are independent. Also, probability of B given A will be equals to probability of B. It follows that, right? These are called independent events. Right. Questions. Question number 1. When a die was thrown, the score was an odd number. What is the probability that it was a prime number? When a die was thrown, the score was an odd number. What is the probability that it was a prime number? So we're being asked to find the probability of a prime number given that an odd number is already occurred. So it will be probability of a prime number, let me write P, given that an odd number O is already occurred. It will be probability of prime intersection odd over probability of prime of odd number. Then let's find the probability of odd number. What's the probability of an odd number? Is this one is a die thrown once, so it's 1, 2, 3, 4, 5, 6. These are the signs on a die. So probability of an odd number, odd, we have 1, 3 and 5, right? Then prime we have 2. Let me use a different ink here. Prime we have 2 and 3. So these are prime. So if you can check, and also 5 is prime, right? Because 5 is no factors, only 2 factors, 1 and itself, right? So you have so odd numbers is 1, 3, 5. Then prime numbers we have 2, 3, 5. So can we check the numbers which are odd numbers at the same time as prime numbers? That's the intersection. We have 3 and 5, which means there are only 2 numbers. So it will be 2 over 6 over or divided by, then probability of odd. How many odd numbers do we have here? We have 1, 3 and 5. So there are 3 odd numbers over 6. This will be 3 over 2 over 6 divided by 3 over 6. It will give you 2 over 6 times 6 over 2 over 3. Then 6 will cancel out. You get 2/3. So it will be 2 over 3. Then you can say done. Next question, number 2. Question number 2. Right. In a certain college, 65% of the students are full-time students. 55% of the students are female. 35% of the students are male full-time students. Find the probability that a student chosen at random from all the students in the college is a part-time student. Part-time student. So it's either they are full-time or part-time. We're given that full-time they are 65%, right? Which means part-time is 100% minus, or if you can write probability of full-time 0.65. Then it means probability of not full-time, that is part-time. Part-time is equals to, you can say 1 minus probability of full-time, which is equals to 1 minus 0.65, which is equals to 0.35. Like this. Then next question, part B. A student chosen at random from all the students in the college is female and a part-time student. So is female and a part-time student. That's part A. Then part number B. Probably that is female intersection part-time student. Right. We are given that 65% of the students are full-time students. Then 55% of the students are female. Then from this, you can say probability of males, they are supposed to be 1 minus female, 0.55, which is 0.45. Or you can call it 45%. That's probability of male. Then 35% of the students are male full-time students. We're given up here that 65% are full-time students. Right? 65 are full-time. Then 35 are male full-time. Which means female full-time, how many are they? It will be 65 minus 35. Female full-time. Female, let me write a female full-time is equals to 65% minus male full-time, which is 35%. What we get here is what? Let me write it here. 65 minus 35 is actually 0, is 30%. So 30% represent female full-time, right? So these are female full-time. What about female part-time? These are female, probability of female and full-time, right? Full-time. Then what about female part-time? We can just say probability of female and part-time. Let me write part-time here is equals to, right, come up here. Females, how many are they? We have 55 females, right? And on these 55 females, they can either be part-time or full-time. So female full-time, they are 30%. What about female part-time? It's 55% minus 30%. 55 minus 30%, which is equals to 55 minus 30. You can simplify here, is 5, then 25. So it's 25%, which means probability it will be 0.25. Then done, right? You can also use sets to solve these things, but let me finish up using this method. Then next part C. Find the probability that a student chosen at random from all the female students in the college is a part-time student. Part-time student. So we are given that we have 65% students are full-time students. Right? A student chosen at random from all female students. Here we are supposed to take from only female, right? So we are choosing from female students in a is a part-time student, right? So in this case we can say probability we are taking from female, In other words, we're given a condition. So part C is probably that the student, given that we're taking from females, right? So it's probability of choosing what? A student is chosen at random from all the female students in the college is a part-time student. So probability of part-time, given that we are taking from females, is equals probability of part-time intersection females over probability of females. Part-time intersection female, you have already found it here, is 0.25. So it will be 0.25 over probability of females. How many females? Is 55% are females. So it will be over 55% or 0.55. In this case, we can say 0.25 divided by 0.55, you get 5/11. Then we can say done. Right, next question. Question number 3. A group of girls at a school is entered for advanced level mathematics modules. Each girl takes only module M1 or module M2 or both M1 and M2. This statement means that there is no girl who is not doing any or taking any of these modules, right? These are called exhaustive events. So events M1 and a student taking M2, they form the universal set, right? Which means probability of M1 union M2 is supposed to give you 1, which means they form the universal set. These are exhaustive events from that statement. Then the probability that a girl is taking M2, given that she's taking M1, is 1/5. It's a condition that you are given. Probability that a student is taking M2, given that she's taking M1, is equals to 1/5. If I'm to simplify this one, it will be probability of M2 given M1 is M2 intersection M1 over probability of M1 is equals to 1/5. Let me see what is right. Then next, the probability that a girl is taking M2 given M1, given that she's taking M2, is 1/3. So probability of M1 given M2 is equals to 1/3, like this, which means probability of M1 intersection M2 over probability of M2 is supposed to be 1/3. Right, now we're here. Then they say find the probability that a girl selected at random is taking both M1 and M2. Both M1 and M2, that's the intersection, right? Intersection, if you can try to have a look here, probability of M2 intersection M1 is the same as probability of M1 intersection M2, right? We can represent this using a letter. We can call this letter Y, right, or XN letter of the alphabet, so as to avoid working with these big numbers, right? So you can substitute here. You can say Y over, on this part, Y over probability of M1 is equals to 1/5. So you can say let the probability of P M1 intersection M2 be Y. Then from this you can cross multiply. 5Y is equals to probability of M1. So probability of M1 is actually equal to 5Y. Let's find probability of M2 using the same concept. M2 using the same concept, right? M2, we can put Y here over probability of M2 is equals to 1/3. Then cross multiplication, it will be 3Y is equals to probability of M2, like this. Then since these events, they are exhaustive events, we can say, right, probability of M1 plus probability of M2 minus probability of M1 intersection M2 is equals to 1. right? So it's supposed to be 1. Then both this one, remember, is probability of M1 union M2, which is supposed to be 1. So again, equate to 1 in this case. M1 is 5y, probability of M2 is 3y, minus probability of M1 intersection M2 is y. It's supposed to give you 1. Then simplify, 5y plus 3y, 8y, minus y is 7y. Is equals to 1. Divide by 7, you get y is equals to 1 over 7. That's the probability of M1 intersection M2. Then we can say done. Right, next question, part B. A girl, find the probability that a girl selected at random is taking only M1. Only M1, it means not M2. Right, we can say here, only M1, it will be, where are you, my space? Let me just write it here. Probability of only M1 is equals to, is probability of M1 minus probability of M1 intersection M2. It's more like a set. If it's a set here, a set is more like this. M1 and M2 here. So M1 only is this part only, this part. It means you have to say all M1 there minus the intersection, so that you can get M1 only. Right, let me do the working here, which means M1 was what? M1 was 5y here. 5y minus y was 1 over 7. So it's 5y minus y, which is equals 5 times 1 over 7 is 5 over 7 minus 1 over 7, which is equals to 4 over 7. We can say done. Right, next question. Question number 4. The events A and B are such that probability of A is equal to 0.45, probability of B is equal to 0.35, and probability of A union B is 0.7. Find the value of probability of A intersection B. Right, A intersection B, we can say probability of A union B using the concept of combined events is equal to probability of A plus probability of B minus probability of A intersection B. From this you can just substitute 0.7 is equals to 0.45 plus probability of B 0.35 minus probability of A intersection B. And from this you can say probability of A intersection B is equals to 0.45 plus 0.35 minus 0.7. Then find your calculator. 0.45 plus 0.35 minus 0.7 is 0.1. Then we can say done. Next, that was part A. Part B, explain why the events A and B are not independent. If they are classified to be independent, then probability of A intersection B must be equal to probability of A times probability of B. So if they are not independent, then these events must not be the same. Their probabilities must not be the same, right? A intersection B is 0.1 must be equal to, then probability of A is what here? 0.45 times probability of B is 0.35. Right, then simplify this. 0.1, is it the same as 0.45 times 0.35? 0.45 times 0.35, you get 0.1575. And in this case, you can say these two things are not the same. Therefore, event A and B are not independent events. Then find the value of probability of A given B. Probability of A given B, probability of A, that's part C, A given B is equals to probability of A intersection B over probability of B, which is equals to A intersection B, I've already found it here, is 0.1. So it's 0.1 over probability of B, it's 0.35. 0.35. Right, using a calculator, 0.1 divided by 0.35 is 0.286 to three significant figures, 0.286. Then you can say done. Right, next question. Next question. The events A and B are independent and are such that probability of A is equals to X, probability of B is X plus 0.2, and probability of A intersection B is equals 0.15. Independent events, they don't have intersection in this case, right? Find the value of X. To find X, you say probability of A times probability of B must be equal to probability of A intersection B. So probability of A is X times probability of B is X plus 0.2 must be equal to intersection is 0.15, like this. Then from this you can remove the bracket, X squared plus 0.2x is equal to 0.15. Then you can express as a quadratic equation and use the quadratic formula to simplify this one or solve this one. You can use completing the square method. Completing the square, you write X here plus half the coefficient of X, which is half of 0.2, which is 0.1, then squared, minus half the coefficient of X, which is 0.1, squared is equal to 0.15. That's what you do here, completing the square method. So you say X plus half the coefficient of X. Coefficient of X 0.2, so half of that is 0.1. Then you put inside the bracket squared, then subtract half the coefficient of X, then squared, which is 0.1 squared. Then from this you can say X plus 0.1 squared then is equal to 0.15 plus 0.1 squared. Simplifying this one, 0.15 plus 0.1 squared, you get 0.16. X plus 0.1 squared is equal to 0.16. Right? Further, it will be X plus 0.1 is equal to square root of 0.16. It will be plus or minus square root of 0.16. Then X will be equal to minus 0.1 plus or minus square root of 0.16 is what? Square root of 0.16 is 0.4 plus or minus 0.4. Then X is equals to minus 0.1 plus 0.4 or minus 0.1 minus 0.4. Then if you can simplify here, you get here 0.3, or here you can get minus 0.5, for which this one X is the probability, right? So probability of A can't be negative, which means this negative answer, we don't need this one, right? So we're supposed to take only 0.3. Then from there we found X, actually that the value of X that we have to use is 0.3. So X is equal to 0.3. That's the answer. Then next, part B, find probability of A union B. That's part B. A union B is equals to, you say probability of A union B is equals to probability of A, which is 0.3, plus probability of B, which is 0.3 here, plus 0.2 is 0.5, minus probability of A intersection B, 0.15. Take note. Then this one will be 0.8 minus 0.15. 0.8 minus 0.15, you get 0.65. Then you can say done. Next, probability of A complement given B complement. That's part C. A complement given B complement. probability of A complement given B complement is equals to probability of A complement intersection B complement over probability of B complement. Right, to get this one, you must present in set notation. That is easy that way. We have to find B complement, A complement. Let me use this space. Right, we have A, then B, A, set B. Right, then universal set is equals to 1. A complement. Right, probability of A is what? Let me start with intersection. Intersection 0.15. 0.15. Then probability of A is X, which is 0.3. Then of B is 0.3 plus 0.2 is 0.5. So 0.3 and 0.5. 0.3 and 0.5. Then A only is 0.3 minus 0.5 minus 0.15. Then B only 0.5 minus 0.15. Right, 0.3 minus 0.15 minus 0.15, you get 0.15. Then 0.5 minus 0.15, you get 0.35. Then if we can add all these things, subtract from 1, you find what is outside A and B. So you say 0. Which means probability of A complement intersection B complement is equals to 1 minus probability of A union B, which is equals to 1 minus A union B, 0.15 plus 0.15 plus 0.35. You just add all these probabilities. It will be 1 minus 0.15 plus 0.15 plus 0.35, 0.65, which is equals to 0.35. That's probability of A complement intersection B complement. So you come down here, probability of A complement intersection B complement is 0.35 over probability of B complement. What is outside B? In this case, outside B in B is 0.5, which means outside B, B complement is equals to 1 minus probability of B, which is equals to 1 minus 0.5, which is equals 0.5. That's B complement. So you say over 0.5, which is equals to, then divide the two, 0.35 divided by 0.5, you get 0.7. Then you can say done. Next question. Question number 6. Two events A and B are such that probability of A is equals 8 over 50. Probability of B is 1 over 3. Probability of A given B is 1 over 5. Then calculate the probabilities that both events occur. Both events occur is probability of A and B, or intersection B, which is equals to, you can use our formula there, probability of A given B, probability of A given B is equals to probability of A intersection B over probability of B. Just substitute here. A given B is 1 over 5. Use different ink here. So it's 1 over 5 is equals to A intersection B. That's what you want here. Is probability of A intersection B over probability of B is 1 over 3. So 1 over 3. Then you can do cross multiplication. It will be 1 over 5 times 1 over 3, is equals probability of A intersection B. Then it will be 1 over 15 is equals probability of A intersection B. So it will be equals to 1 over 15. Then going up there, B, part B, calculate the probabilities that only one of the two events occur. Only one is not A and B will occur, or A will occur and B will not occur. Only one of the two events occur. Right, that one will be is either probability of A will occur and B will not occur, or probability of A will not occur and B will occur, like this. Then it will be probability of A plus probability of A will not occur but B will occur. Then substituting here, probability of A and not B. Let me find probability of A, not A first. Probability of not A is equals 1 minus probability of A, right, which is equals 1 minus 8 over 15, which is equals 7 over 15, right. Probability of not B is 1 minus probability of B, which is equals to 1 minus 1/3, which is equals to 2 over 3. Then not A, 7 over 15. Not A here, if I can substitute here, it will be not A and B. A is what? Is 8 over 15 times not B is 2 over 3 is there. Then plus not A is 7 over 15 times not B times B, which is 1 over 3. Then if you can simplify this, you get 16 over 15 by 3 is 45 plus 7 over 45. Then add the two together. 16 plus 7, you get 23 over 45. Then we can say done. Then say Mangeya, the Maths Eagle, signing out. Thank you.